46 billion light-year away, there stands an invisible wall that marks the edge of everything we can ever see or know. Beyond this cosmic horizon lies a realm so mysterious that even our most advanced theories can only guess at what lurks there. We will journey past dying stars that rain liquid metal through voids so vast they could swallow 1,000,000 galaxies, and into dimensions where space itself might be an illusion. If you are ready to explore what lies beyond the edge of reality, hit that like button and subscribe, because we are about to venture where no human eye has ever looked. Prepare yourselves. We begin. Music, picture standing at the edge of a cliff, but instead of rocks below, there is nothing but endless mystery. This is where we find ourselves when we reach the boundary of the observable universe. A sphere stretching 93 billion light-years across, with Earth sitting right at the center. You might think this edge is where space ends, but you would be wrong. This invisible wall exists not because space stops, but because light itself has limits. When you look at distant galaxies through the most powerful telescopes, you are actually looking backward through time. The light from these cosmic neighbors took millions or billions of years to reach your eyes. The farther you peer into space, the deeper you travel into the past. Eventually, you reach a point where the light has been traveling for so long that it carries images from when the universe was just 380,000 years old. A cosmic baby compared to its current age of nearly 14 billion years. This ancient light creates our cosmic horizon. Beyond this boundary, space continues to exist, filled with galaxies, stars, and planets we will never see. These hidden realms stretch outward in every direction, containing wonders that dwarf anything we have discovered in our local cosmic neighborhood. Imagine entire galactic clusters the size of our local group spinning through the darkness just beyond our sight. Scientists estimate that for every galaxy we can observe, there are at least 23 more hiding beyond the edge. These invisible galaxies follow the same physical laws as ours, hosting planets where alien sunrises paint foreign skies in colors we cannot imagine. Some of these worlds orbit stars so massive they would make our sun look like a grain of sand next to a basketball. The strangest part about this cosmic boundary is that it moves. Every second, light from slightly more distant regions reaches Earth for the first time, pushing our observable horizon outward at the speed of light. We are constantly discovering new territory, like explorers whose map expands as they walk. Yet, this expansion happens so slowly that in a human lifetime, the edge moves only about 6 trillion miles farther out. A distance that sounds enormous, but represents just a tiny fraction of a light year. What makes this boundary even more mysterious is that different observers throughout the universe each have their own unique horizon. An alien astronomer living in a galaxy near our current edge would see completely different cosmic territories than we do. Their observable universe would overlap with ours in some regions, while revealing entirely new cosmic landscapes in others. Think of it like standing in a vast foggy field where you can only see a certain distance in any direction. Move to a different spot and your circle of visibility shifts, revealing new areas while hiding others. The universe works the same way, with each location serving as the center of its own observable sphere. But this wall of light is just the beginning of our journey into the unknown. Because what lies beyond makes our visible universe look like a single raindrop in an infinite ocean. The oldest light in the universe whispers secrets about what lies beyond our cosmic horizon, and it comes from everywhere at once. This ancient glow, called the cosmic microwave background radiation, fills every cubic inch of space around us. When you tune an old television to static, about 1% of those dancing dots comes from this primordial light. Photons that have been traveling through space since before the first stars were born. This radiation marks the moment when the universe became transparent for the first time. Before this cosmic dawn, space was so hot and dense that light could not travel more than a few inches without being absorbed or scattered. The entire universe glowed like the surface of the sun. But this light was trapped in an endless maze of bouncing particles. Then, as the expanding cosmos cooled, electrons and protons finally joined together to form the first atoms. Suddenly, light could travel freely across vast distances. The universe went from being opaque to crystal clear in what astronomers call the moment of last scattering. This transition happened everywhere simultaneously, creating a sphere of glowing gas that surrounded every point in space. The light from this cosmic flashbulb has been racing. Quantum fluctuations that were stretched to cosmic proportions during this inflationary epoch. These tiny variations in the quantum foam became the seeds that would eventually grow into galaxies, galaxy clusters, and the cosmic web. In essence, we are seeing the quantum mechanical birth cries of cosmic structure itself. But this sphere represents just the beginning of our journey backward through time. Because the universe underwent even more dramatic transformations in the moments before it became transparent. In the invisible realms beyond our cosmic horizon, vast kingdoms of dark matter weave through space like ghost empires. These shadowy domains contain 5 times more mass than all the stars and galaxies we can see. Yet, they remain completely invisible to our most powerful telescopes. What we observe in our local universe represents just the glowing tips of cosmic icebergs. While the real bulk of matter lurks hidden in the darkness, dark matter particles stream through your body right now at speeds of hundreds of miles per second. Millions of these invisible bullets pass through every square inch of your skin each second. Yet you feel nothing because they barely interact with ordinary matter. They are like cosmic ghosts present everywhere, but touching nothing. This ethereal substance shapes the architecture of the universe while remaining forever beyond our direct perception. The hidden universe contains dark matter structures that dwarf anything made of ordinary matter. Imagine cosmic scaffolding built from invisible threads with galaxy clusters hanging like holiday ornaments from a framework we cannot see. These dark matter halos extend far beyond the visible edges of galaxies, creating spheres of invisible mass that can stretch for millions of light years. Computer simulations reveal that dark matter forms intricate cosmic webs throughout the universe. These simulations show vast filaments of dark matter connecting distant galaxy clusters with enormous voids stretching between them. The largest dark matter structures span hundreds of millions of light years, creating a cosmic architecture that exists primarily in the hidden universe beyond our observable boundary. Some of these dark matter kingdoms exist in total isolation, containing no ordinary matter at all. These ghost galaxies would be completely invisible to us, even if they were sitting right next to the Milky Way. They represent pure gravitational sculptures shaped by forces we can detect only through their effects on nearby visible matter. Entire cosmic empires could exist in these dark realms governed by physics we are only beginning to understand. The dark matter in our observable universe shows patterns that extend far beyond what we can see. Galaxy surveys reveal that dark matter halos are aligned across distances of hundreds of millions of light years, suggesting that the invisible scaffolding follows organized patterns throughout the broader cosmos. These alignments point toward dark matter superstructures that stretch across our cosmic horizon into the hidden universe. Scientists have discovered that dark matter moves differently than ordinary matter in the early universe. While normal matter got caught up in the cosmic plasma and could not form structures until after the sphere of last scattering, dark matter was already building cosmic architecture during the universe's first few hundred years. This head start means that the dark matter universe developed a more complex structure than the visible cosmos we see today. The gravitational effects of dark matter also influence the cosmic microwave background, leaving subtle fingerprints that reveal information about the hidden universe. These patterns show that dark matter was already forming massive structures when the universe was just a few hundred years old, creating gravitational wells that would eventually become the largest galaxy clusters. Beyond our cosmic horizon, dark matter continues this architectural project on scales we can barely comprehend. The hidden universe contains dark matter structures so massive that our entire observable cosmos might fit comfortably inside just one of their gravitational halos. But dark matter represents just one component of the invisible universe. because an even more mysterious force is actively reshaping cosmic architecture on the grandest scales imaginable. Before the cosmic microwave background formed, the universe underwent the most violent expansion in cosmic history. During the first tiny fraction of a second after the Big Bang, space itself stretched faster than the speed of light, growing from smaller than a proton to larger than a grapefruit in less time than it takes light to cross an atomic nucleus. This inflationary epoch explains why regions beyond our cosmic horizon exist at all. Imagine a deflated balloon with two ants sitting right next to each other on its surface. Outward ever since, and we see it today as a faint microwave glow that bathes the entire sky. This background radiation carries a map of the early universe written in tiny temperature variations. Some regions were slightly hotter than others, and these differences show us where matter was beginning to clump together. These hot and cold spots would eventually grow into the cosmic web of galaxies and galaxy clusters we see today. The pattern reveals not just our past, but hints at the massive structures that exist beyond our observable boundary. The temperature differences are incredibly small. We are talking about variations of just a few millionth of a degree. Yet these tiny fluctuations represent density variations that stretched across regions millions of light wide. When we map these patterns, we can trace them beyond our visible horizon and predict what kinds of structures should exist in the hidden universe. Scientists have discovered that the microwave background shows evidence of features larger than our entire observable universe. These cosmic superstructures appear as subtle patterns that suggest our visible cosmos is just one small section of a much grander architecture. It is like finding the edge of a massive city by studying the pattern of streetlights visible from your neighborhood. The radiation also carries clues about the shape of space itself. By measuring how the hot and cold spots are distributed across the sky, astronomers can determine whether the universe is curved like a sphere, saddle-shaped like a mountain pass, or flat like an infinite sheet of paper. The answer has profound implications for what lies beyond our cosmic boundary. Current measurements suggest space is remarkably flat, which means it probably extends infinitely in all directions. This flatness implies that the regions beyond our horizon contain the same kinds of galaxies, stars, and planets we see in our local cosmic neighborhood, stretching onward without end. But this ancient afterglow is about to reveal something even more mind-bending about the true scale of reality. Deep within the cosmic microwave background lies a hidden sphere that represents the farthest we can ever see into the past. This sphere of last scattering surrounds us like a cosmic snow globe, marking the exact moment when the universe first became transparent. Beyond this ancient boundary, the laws of physics themselves conspire to hide the deeper mysteries of space and time. The sphere sits at a distance of 45 billion light-years from Earth, even though the light took only 380,000 years to reach us. This mind-bending contradiction happens because space itself has been expanding while the photons travel toward us. Picture an ant walking across a balloon that someone is steadily inflating. The ant moves forward, but the balloon's surface stretches beneath its feet, making the final distance much greater than the path it walked. When we peer at this sphere, we are witnessing the universe at just 1,700th of its current age. Back then, the entire cosmos was only about 3,000 degrees F, hot enough to melt copper, but cool enough for the first atoms to form. The universe had shrunk from the size of a grapefruit to roughly 1,000th of its current scale. Yet, it still stretched farther than we can imagine. This ancient sphere reveals patterns that extend far beyond what we can see today. The hot and cold spots and the microwave background show correlations across distances larger than our current observable universe. These patterns are like seeing parts of a vast painting that extends beyond the edges of your window frame. You can tell there is more artwork outside your view, following the same artistic style and color scheme. Scientists have identified features in the sphere that span angles larger than 2 degrees across the sky. This might sound small, but remember that we are looking at the most distant observable surface in the universe. An angle of 2 degrees at this cosmic distance represents a physical size of about 1 billion light-year. The fact that these enormous regions show coordinated patterns suggests they were once close enough together to influence each other. The sphere also shows us that the universe was incredibly smooth in its youth. The temperature variations across this ancient surface differ by only about 1 part in 100,000. This smoothness creates a puzzle because regions on opposite sides of the sphere could never have communicated with each other through light signals. Yet somehow they managed to reach almost exactly the same temperature. This puzzle points towards something extraordinary that happened before the sphere of last scattering form. The universe must have undergone a period of incredibly rapid expansion that stretched small connected regions to enormous sizes. During this cosmic inflation, areas that were once neighbors became separated by distances larger than light could travel. The patterns frozen into the sphere of last scattering represent